Hi all, welcome to our webinar on comprehensive risk-based API protection. I'm Saket, the product marketing manager at Indusface. This webinar would be of 45 minutes long and has been designed as a fireside chat, post which you could ask your questions to the panel and we'll happily answer them immediately. Before we get into the intricacies, here's a brief introduction to Indusface. Indusface is a leading application security SaaS-based company funded by Tata Capital with 3,000 plus global customers using our fully managed PCI, ISO, SOC, and GDPR compliant application security platform named AppTrana that provides web application and API protection. We as a company provide risk-based managed protection and acceleration of websites and applications. We have an experienced management team. Founders sold their last SaaS security venture to Trend Micro. We are a multi-million-dollar company growing at the rate of 45% year on year, with a net customer retention rate of 110%. We have product integrations with leading MSSP cloud CDN providers such as TCS, AWS, and Tata Communications. Indusface AppTrana has been rated as the customer's choice in all the 7 segments of Gartner Peer Insights Voice of Customer WAP 2022 report. We are the only vendor with 100% recommendation rating for the second year in succession. We're the customer's choice in all the deployment regions, APAC, EMEA, and North America. We're the only vendor to be rated as the customer's choice in the services industry as well. We're the customer's choice in both the mid-market and large enterprise segment as well. Now, let me introduce you to our esteemed panel of speakers. Mr. Vivek Gopalan, the head of product management. At Indusface, Vivek heads the product management and is responsible for defining the product direction. He has worked with multiple domestic and international startups. He's an expert on cloud architecture, dynamics of public cloud like AWS, Azure, and the SaaS business model. Moving to another tech speaker, Mr. Karthik Krishnamurthy, the Chief Technology Officer at Indusface. He heads the R&D and security research. He's responsible for overall technology strategy, architecture, and innovation with a focus on future security, web, and cloud trends. Before Indusface, Karthik worked in technical and leadership roles for companies such as Intel and Trend Micro. Now let's get into the crux of this webinar. Over to you, Vivek and Karthik.
Hey, thanks, Saket. Yes, we do have a combined lot of years of experience in the industry and in security. So, Vivek, I'll ask you a question that our customers probably have in the audience. Is Indusface has been doing API protection as well as web application security solutions for years now. So why did Indusface decide to invest specifically in API security solutions?
Yeah, thanks, Karthik. I think that's a good point to start with, right? Yes, Indusface has been protecting both web applications and APIs for a while now. And generally, both web application APIs have commonalities, and the security models can be used for both, right? And initially, when we were developing the protections in AppTrana, we were building our security models which would work for both APIs and web applications, right? But as we see now, the landscape is more evolving, and more the businesses are relying on APIs. And what we are seeing is the threat landscape is itself evolving, right? And the more and more the attack surface areas are being targeted towards APIs. And that's the reason why we thought that now API has to be given a special attention, and we have to provide an API specific solution. Even recently, the OWASP has released an OWASP API specific top 10, right? Top 10 threat vectors. This is essentially talking about what are the top 10 attacks that is happening around APIs. Many of these would be similar to what is happening on web applications, but some would be different. And that's the reason, right? So there are uniqueness about APIs because of the characteristics of these APIs, because they are well structured, they are publicly available, it's a machine-to-machine communication. So because of these natures, the API's characteristics is unique, and it made sense for us to build an API-centric solution which will address the evolving threats, right? So that's the reason why we ended up deciding to build an API security solution, and that's why we have built it. So Karthik, I'll then throw the next question to you, right? So when we decided that, okay, we have to do an API-centric solution, we also thought about how do we do it, right? And we brainstormed a lot. And we did discuss about some of the challenges that comes with APIs. Why don't you talk a bit about that?
Sure. Yeah. So what I'm actually going to do is contrast API security and web application security and see and show why API security has to be thought about by itself, not as just a little addition to web application security. So there are similarities in the API and web application security, but there are some differences or challenges as well. One of the first things is discovery. As in the web application world where we could use a crawler, for APIs, you cannot just crawl APIs. That is one challenge, definitely. How do you discover APIs? And this, and part of that is because consumers of APIs need not be the browser. Consumers of web applications often are browsers. This need not be the case in API world, because mostly APIs are called by other processes. So it's generally a machine-to-machine, bot-to-bot kind of communication, or bot-to-API kind of communication. The other big thing that has changed, in the way the web is being used, including because of mobile phones and stuff, is microservices. So where earlier it used to be a request served by a web application, and that was the loop. Now a request, whether it is due to user action or whether it is because of some automated thing that is constantly happening, it gently fires a request. Even if it's coming from the browser, there will be something that will be fired to an API. That API in turn will make more requests and things like that. So there is an explosion in the number of requests being made to APIs from either the browser or from other processes. And that is also a challenge, that there is so many microservices, so many APIs. One other thing that I would highlight is shadow APIs. Even for organizations that actually have a compliance mandate or security team and the documentation tested before release kind of cycle for APIs, there is, and which includes security testing, which very few organizations do. But even for those people, the challenge they have is that developers, it's easy for them to add APIs. It's easy for them to change parameters to API or add an additional parameter, which may not be known, and that might open security loopholes. And there are numerous such cases, even for big companies like Facebook and stuff. So this is the challenge of shadow APIs as well. How do you test what you don't know? And in terms of protection and stuff like that, there is stuff that there is tools and attacks that are there in web application world also, like DDoS and bot and things like that. But APIs, the way to detect and the way to protect against these has to be specific to APIs. So there is enough similarities, but there's enough differences that you need that it is challenging enough to do specific API security. When I think about DDoS, though, Vivek, one question that does come up is, hey, why not just use API gateway as API security? Why do I need anything else? I will use an API gateway anyway. Why isn't that sufficient? So that is something that I'd like you to jump in and try and answer.
Sure, Karthik. So yeah, that is a very common question that I'm hearing from a lot of my customers, right? They generally say, hey, I have an API gateway. Now, do I need an API security solution? So in this context, what customers need to understand is API gateway is more an API management solution. It is built for more on how to create an API, deploy an API, and then doing version controlling. This is what API gateways are meant for, right? And that's where they are good at. From the security standpoint, they probably play in two areas. One is the authentication and authorization part, where they are definitely good at. And the other part is around the throttling side of things, right? So most of these API gateways have some kind of rate controls, which will allow you to throttle the number of requests that is coming from a client to an APIs. But here also, any good API security solutions would do a lot more than a simple static rate limits, right? For example, AppTrana has a behavioral-based rate controls, which looks at the behavior of those APIs and then provide rate controls around that, right? Which is more sophisticated in nature. But just looking at API security in isolation, right? API security itself plays a different role than an API gateway. API security is meant for looking at the request that is coming to the APIs, understanding if there are any attack patterns there, understanding the vulnerabilities that are there in the APIs, and trying to see if there are any requests coming to exploit that. That is what is API security modules are meant for. They also do certain things like bot mitigations and the DDoS protection, which I talked about. That's where API security plays a major role, and this is not something what API gateway does, right? So what I generally tell my customers is that when you kind of compare API gateways and API security solutions, they are not an replacement of one another, right? It's more a complementary solution. You would generally need both API gateways and API security solution to ensure proper deployment, management of your APIs, and ensuring that your APIs are secure, right? With that, Karthik, what I would want to do now is go into a bit more specifics, right, of how we do things in AppTrana. So you did talk about the challenges that comes with API security. Why don't you throw some light on how we went about mitigating those challenges, especially from the risk detection side of things?
Sure. Thanks, Vivek. So yes, from the detection point of view, from a scanner point of view, one thing is, of course, is that we did, since we already have a web application scanner, we leveraged the technology and built upon it. But there is specific things being done for the API. One of the things that we had to do was to solve the whole discovery and flow problem. Was that we are using postman files. We ask customers to upload their postman files. Now, postman is a standard that most organizations, most developers and QA will be using to test their web applications in any case. So we can understand the postman file to know the APIs, know the parameters to use for the APIs, the values for the parameters, as well as sequences, because postman allows you to define that this API depends on the other API. So you have to call that first and then call here. For example, almost everything will need a login session. Then the other thing is also the flow, right? That, okay, this depends on this and that can depend on something else. So you know the sequence that you can run the APIs in. That's one thing that we did and where we solved it. The other thing that is different in APIs, especially from the scanning point of view, is authentication. There is no browser-based authentication here. This is APIs. So we had to add other support for more authentications, like APIs typically use token-based or secret key header kind of based authentication, as well as OAuth without a browser involved, completely in the protocol-based authentications. So these are the kind of things that we had to add support for, little extra things. Then speaking about the core detection itself, we have plugins, and there are plugins that are common to API and the web world, the web application. But the way to detect the vulnerability is different in API. Once again, it's because there's no browser on the other side that you can use to hook into and figure out things. The responses are JSON or some other structured format often, and not a rendered HTML, or not an HTML that's going towards rendering. So the way to detect it does change. And finally, even from the detection plugin point of view, we did write API specific plugins that we have to do that makes most sense in APIs. So we focused a lot more on that using the OWASP API top 10. For example, insecure direct object references is something that is more commonly, the focus is more on the API side of things than the web application side of things. So from detection, if you move to protection, Vivek, why did you think that we needed a specific way to protect APIs as opposed to just adding more rules? We already had API rules in WAF. Why not just add more rules? Why build a specific API protection?
Yeah, Karthik. I mean, that's a good point. And as I already mentioned, right? Yes, we could have used the modules, security modules that we were using for web applications, and obviously we did borrow some of those, right, when we built the API protection solution. But the reason why we taught a specific API specific protection modules were required was because of the nature of the APIs. As I already mentioned, the APIs by itself are different, right? It's more used for machine-to-machine communications. So, and generally it is used by third parties, right? So the structure of these APIs had to be documented, had to be exposed to the customers. That's the only way that the APIs could be used. So what that also meant was it opened up a threat vector, right? Where hackers could look at these APIs, would look at these documentations, reverse engineer, and exploit those. So that's essentially what was happening when the API world, and what was required was a bottom-up solution for APIs, where we had to take this advantage of that definition and well-documented structure and use it for the advantage of security. And that's what we have done in AppTrana, right? We are now using these definitions to create a positive security model in AppTrana. So when a customer wants to protect any APIs behind AppTrana, we ask customers to provide us Swagger files which has definitions of their APIs. For example, that it could have an API 1 which has 10 parameters, and first parameter could be integer, second could be a string, third could be an enum, and so on, right? And now if anyone, we would create a rule or policy around this. So now when anyone tries to access these APIs, we'll check for whether that API 1, when they are accessing the or requesting these API 1, it has 10 parameters, as the first parameter is an integer, second is a string, third is an enum, and so on. So we look for it, we look whether the request conforms to the definition, and if not, we block it. So the advantage of this is it reduces the risk surface for attacks, right? There's only so much that the attacker can do now. And for that also, we have a negative security model, which is built ground up, right? For APIs, where we have an API specific policies based on the API threat vectors that OWASP has defined, ensuring that the protection is comprehensive. And not only that, we had to also take into account about the shadow APIs that you talked about. So shadow API is another major problem, and we had to build solutions around that. And that's another reason why we need a unique solution for APIs. And last but not least is about around the DDoS and the bot mitigations, right? Generally, as I said, APIs are machine-to-machine communication. Now, that what is a bot when it comes to the API world? It's not. I mean, in the web world, we'll try to differentiate between human and bot traffic and try and put risk scores to bot using general methods like JS challenges, captchas, and the likes. But that doesn't apply in the API world, right? Because all requests are machine-to-machine, all requests are bot traffic. So now we have to build a ground-up solution where we looked at the behavior of these requests, how the requests are being made to these APIs, and then try to differentiate whether those machine communications were actually good or bad, differentiating between a good bot or a bad bot. So those are the primary reasons why we had to build an API protection solution.
Cool. I just want to chime in here with one small thing, is that for AppTrana, we did also manage to actually, what we did in web application security is our core way of security works around the risk-based approach, which is we find the vulnerabilities, show you a security posture, and then protect it. So even for APIs, we did follow the same philosophy, and we took some time to do that. And that means what our API scanner, the vulnerabilities it finds, we will tell you in the AppTrana portal whether those vulnerabilities are blocked by our core rule set and negative rules, whether it is blocked by positive security rules, whether they should customer needs to request custom rules to block it, or whether it cannot be fixed by any security solution. They should fix their app or config to fix it. So this is also a very nice or unique thing that that AppTrana brings to the API security world.
Thanks, Karthik. I think that's great, right? And yeah, or the risk protection or the risk-based protection that we provide in AppTrana is a unique piece that provides a complete picture to the customers and give a comprehensive API security to our customers. With that, Karthik, I mean, I think I would want to add an additional question to you, which is around, I did talk about how we build why we build an API protection layer. Why don't you talk a bit around the implementation challenges when you had to go about and build the API protection module?
Yeah. So just like in detection, there is generic challenges or differences with API security, but there are specific challenges when we're implementing as well. So protection has similar challenges, and a big part of it is actually even identifying the API, because unless you know which API it is, things like positive security and all, we don't know which rules to enforce for which parameter. So it's very key to identify the API. And APIs are identified not just by the URI path, but also its method plus URI path. And to add to the complexity, the URI path itself can have parameters. This is the way that many REST APIs are. So a get/product/4, get/product/5, get/product/6. Though there are unique URIs, it's actually get/product. And the product ID is the next parameter, which is the 3, 4, 5. And obviously, there can be multiple dynamic parameters in the URI. Similarly, a get/customer and a put/customer are two different APIs. One is to retrieve customer data, and one is to update or change or add customer data. So there is, and these things in the API world, the method, URI, and this thing also matters. So this was a challenge to make sure that we get that right, make sure we get the dynamic parameter right, make sure we classify the APIs into the appropriate API type, and map it to the OpenAPI file that's uploaded to know that this means that API kind of stuff. So that was an interesting challenge that we had to overcome. From a different perspective, not just the coding challenges that we had while implementing the security solution. From our security engineers' point of view, we have a security team who are responsible for providing the actual protection using the security engine that we built. So their challenge was also more along the lines of that APIs are different from web applications. Web applications are typically built using, for certain purposes with certain typical, and now that we've kind of fallen into a few different frameworks, so to speak, like this is a WordPress site, or this is a content management site, the shopping cart site. We've kind of figured out this. And so even the kind of threats that are coming because there's, a pool of frameworks that are used in those situations, as well as our tweaking of if a customer reports that, hey, look, this particular rule is not working well in our environment, and you have to kind of tweak it. We kind of know what the problems are that a particular site might have customized and stuff, right? So we are much more experienced in the web application world. Now, APIs, the big challenge is that APIs mostly in many cases it's custom written by developers. So there's no, I mean, there are a few standards, obviously, but in general, most APIs are custom. And with microservices, whether it's at the microservice level or each individual API level, there's a lot of different developers just building APIs there. So the challenge is there's more vulnerabilities, and as well as any kind of custom tweaks that are needed is also different and often case by case. But the good thing about APIs, of course, is that since they are structured format and documented in a machine readable format, you can actually apply positive security like Vivek explained. So one big challenge there is, you have to suppose you have to properly validate a particular parameter. Now that parameter could be inside a nested JSON object, or a deep inside a nested JSON object, or an array or something like that. So how to do that correctly was also a nice challenge that we had to solve. So these were some of the challenges. I mean, obviously, there are lots of little challenges in all implementation, but these are some of the big, interesting challenges. So Vivek, I mean, I know we've talked about detection, protection, both from the generic point of view as well as specific to our solution. I think it'll be good for the audience to actually see this thing, see this in action. So can you give them a quick demo to show what's happening with our API security solution?
Yeah, sure, Karthik. I think we would give a quick demo here. So this is my API, my AppTrana portal. This is the same portal that we use for web applications also. So how we have built our API security module is we have incorporated into AppTrana, and it's a separate plan. And the workflows that we have built is kind of mirroring how we use it for web applications, so that our customers did not learn the usage of the product again, right? So once you log into the portal, you will get the dashboard like how you would generally get it. Moving on, I have currently onboarded a API host under the API security plan. So onboarding is very similar to how web application gets onboarded. Customer has to give the API host where they have hosted their APIs, and then they have to route the traffic to us. And once they route the traffic to us, the protection will immediately start. So when the protection starts, we have API specific rules that has been created, and those would be applied in block mode from day zero. So how these API security rules work is we have certain set of rules which we are sure that there would be not much of an FPs. So these rules will be put in block mode from day zero, and then we will continually monitor these sites for 14 days. And the remaining set of rules which are in log mode will be monitored for, and we'll see how the traffics to these APIs are triggering these rules. We'll see if there are any FPs. If we are any FPs, then we will tweak those. And once that is done, these policies will be moved to block mode. The best part about this is the entire, all these things happen more or less transparent to the customers. So customers don't do any kind of heavy lifting. They'll be reached out if we need to understand any specific details about the APIs for us to fine tune better. But otherwise, generally, the work and the heavy lifting is done by our team. And the protection will be in full protection mode within 14 days. So in this case, we have onboarded this API host, the protection is on, and then we have also have certain identified certain vulnerabilities. As we already pointed out, one of the advantages of AppTrana is the risk-based approach. And if you can see here, what we are saying is, hey, we have found 10 vulnerabilities. Out of them, 2 are critical, 4 are high, and 4 are medium. And out of these 10 vulnerabilities, 4 are protected already by our default rule sets. 3 of them are protected by our positive security policies. 2 of them can be protected by custom rules. There is an option for customers to request for custom rules, and then 1 of them is already protected because the custom rule is already requested. So now you get a comprehensive view on what is your risk posture and how they are protected. And this is the biggest value add that we provide to our customers, right? So moving on to the detect page, this is where you get more details on the scanning side of things. So you get to know what are the vulnerabilities, what are the specific vulnerabilities. You can go into a granular details of what are to know more about it. And you also get to know how they are protected, right? So you get a very comprehensive view here. Customers can come and start API scans at any point of time. If the postman files are not given, we would ask the customers to give those postman files. But in this case, the postman file is already there, so customers can come here and start the scan. So when the scan is started, few things happen at the backend, right? So when this postman file is uploaded and the scan starts, what happens is a notification goes to our backend team also, who looks at these postman files and sees that if all the details are there, and if there can be any additional details that can be added, which would help our automated scanner to identify more vulnerabilities. This is what we call as annotation of the postman files. This is done by the backend team, and once they do that, they start the scanner for the automated scanner to go and find the vulnerabilities. So what the scanner would do is essentially it will iterate through the postman files like this. It will have further details. So these are some of the annotations that our team does to ensure that the scanning is done properly. And once the scanning is done, the results will be published. Before publishing the results, one more step happens, which is that our manual team again is notified who will cross-verify these vulnerabilities for FPs and ensure that there are no FPs. And they will also look for if any vulnerabilities are missed, because there will be certain vulnerabilities that can be found only through the manual pen testing. So that will also be done. Those results will also be combined and published so that customers get a comprehensive view of their risk posture. Moving on from the protection perspective, customers get a complete view into how the protection is working, the various policies, how they are triggering, what is protected, where are the attacks coming from, which API is being attacked. All these information are readily visible in the portal for customers to drill down. The other part which we already highlighted was the positive security policy. So based on the Swagger files like this, which is already uploaded, what we would do is we would create a positive security policy around it. So for example, say the get account, the authorization key is a string. So we will create a positive security model around that. And if it is not a string, then we will block. So this part is automatically created. And based on that, the protection automatically starts and you get a good visibility into what is there, how it is working and what is allowed and what is blocked, right? Finally, the other side or part of things that I want to quickly brush through is the behavioral DDoS protection for APIs. So we have an behavior-based policies which we have created at the host level, then you can create it at an API levels too, so that the protection can immediately start and behavioral-based rate controls can be provided to protect your API service. We also have bot protection, which is again where we have modules which are API specific, which would help you, which is help us to identify the requests coming to these APIs and determine whether the bots are bad bots or good bots. And for each of these modules, risk scores are automatically added to the identity. And when the risk score goes beyond the threshold, then that will be blocked. So these are the major highlights of our API security policies, right? And the last but not least, because you have given us these Swagger files also. So what you can also do is you can look at the shadow APIs. So these are all the APIs that we know of. And then you can look for shadow APIs if any request that is coming in, which is not part of your definitions, and then see what are those requests and then take course correction around it, right? So those are the things that are possible and that is available as part of our API security. So Karthik, I hope the demo was useful and I hope it was informative. Now, as a closing comments, right, what I would want you to talk about is give a sneak preview into what is in the future, right? I know that you are building a lot of cool stuff around the API security. So why don't you talk a bit about it so that the audience here also understands what we are building for the future.
Let me just give you a quick sneak preview kind of stuff into what we're working on now. So we have an API solution, security solution out, and it's good and it's usable, and customers are using it, and it's providing real protection. But some of the things we discovered as customers are using it, and as we look at the industry and at large, is that one is that APIs undergo rapid change. Both, like we said, the developers change and update it and upload things quickly. As well as documentation often, not just for APIs, I think in general, documentation tends to lag behind the actual implementation in many cases. So to solve these kind of unique things that we are finding in the API world, to solve this kind of stuff, what we are actually moving towards is that we have built technology that can actually understand discovery as well as parameters, as well as types of parameters and flows by looking at traffic that is flowing through our system. So what that means is that, if customers give us their OpenAPI specification, well and good, we'll validate that against their existing traffic if need be. And if they don't give it, we can understand it just by looking at the flow as well and build a positive security using that. So that is something we are working on now, which is auto discovery, including types and parameters and ranges, so that we can add validation and everything. As well as from the scan point of view, the same thing will help to understand the flows of the APIs, so that we can guide the scanner to follow the APIs in the right sequence, which is more likely to not result in API errors just because you called out of order or something. Another side of things that we've done is that Indusface is kind of unique in this space, is that we have an automated scanner, we have protection, as well as a manual pen testing team. So we have all three things. So from the scanning point of view, we want to leverage manual pen testing team, and we already are doing this. In terms of on a site specific thing, if a manual pen testing vulnerability is found, we'll be able to automate it for future scans, and we've gone down that route already. But leveraging more and more of the automated pen testing knowledge for business logic vulnerabilities to scan APIs completely automatic, by building better heuristics, better ways of detecting and things like that. So that's a big effort as well that we are underway, which just enhances the detection for the APIs. So these are two of the things that we are spending our cycles on now.
Great, Karthik. I think that's interesting, and we look forward for those to come out. With that, I think we'll come to the end of this webinar, and I'll hand it over to Saket to handle the Q&A.
Thank you, Vivek and Karthik. Now we open the session for question and answers. You can type in your questions and we'll answer them one by one.
Okay, great. So I think there are a few questions which we can answer one by one. The first question is, what and how attack can happen on APIs? So, attacks can happen on APIs similar to how attacks happen on web applications. Both of these are exposed to the public and to the internet, and essentially those can be exploited. Generally, the exploit happens by identifying the vulnerabilities that are there in these APIs or trying to exploit those vulnerabilities, right? So that's generally how the APIs are attacked. And again, the consequence of those are very similar to what happens to web application. Sometimes it's more, right? Because APIs have access to generally to more sensitive data and the things. So yes, so attacks can happen on APIs very similar to how attacks on web applications. So the next question is, will there be a revalidation of vulnerabilities? So yes, so as part of the AppTrana, we give automated scans and also revalidation, right? So when a scan starts, you give the postman files, and the postman files are annotated by a team, and we ensure that all the vulnerabilities are identified. And because these annotations are also kept updated, what happens is any further scans that can be done to revalidate the vulnerabilities through AppTrana at any point of time. And this can happen any number of times until your application or the postman file doesn't change. The third question is, which standard will be de facto, REST or GraphQL? So currently it's REST APIs. So that's what we are scanning for, and that's essentially what we are protecting. So we're protecting both REST APIs and XML-based APIs. GraphQL is something that we will have in the future roadmap. Somebody has asked, what is the difference between web app security testing and API security testing? Well, it is essentially testing for the vulnerabilities specific to the APIs, right? As I said, OWASP has released an OWASP specific top 10 API threats. There are various checks that has to be done on APIs, which may or may not apply for web applications. And there will be certain vulnerabilities that apply for web applications, do not apply for APIs, right? So it's an API specific test that is done to identify vulnerabilities that are specific to the APIs. Yes, there will be some commonalities between web application and APIs, but there are also uniqueness that we have talked throughout the webinar. Someone has asked, and both the questions, the next both questions are can be answered together. One has asked, what is a URL to register? Other has asked, is there a trial version? So yeah, to register, you can go to www.indusface.com, AppTrana, and register there. You have options to start free trial, or you could also request for a demo. Please go ahead and sign up there, and somebody will reach out to you to get you onboarded on the API security plan. Yes, we have a trial plan for 14 days where you could onboard your API host and test out our features. I think with that, we come to the end of these questions. Thanks for joining in, and thanks for sticking with us till the end of the webinar. Hope it was informative. Please do reach out to us if you have any additional questions. Thank you.